A generation of young people may never be able to own their own homes.
High demand and low inventories pushing up housing costs.
Rents remain red hot.
I would argue that housing is probably our number one or number two political problem in almost every industrialized nation right now, right? And that, in my view, has only one solution. We actually have built 3 main types of robots that work together.
So what you can see here is basically our system doing its thing.
So you're scaling up, right? And we're going to do hundreds of buildings at the same time. The software is the magical part about what we do, despite most people not seeing it.
The company who has the most customers with the most robots out there will also have the biggest amount of useful data.
Yes. I actually used Boston Dynamics specifically as our counterexample. Like, it's a very cool company. They build cool technology, and they've been stuck in like this 30-year-long like R&D mode. And I think that's exactly what we didn't want to be. We are deploying everything. You can see how dirty they are. Like on real construction sites, we're building walls, we're generating revenue.
Hey folks, welcome from the beautiful city of Amsterdam. It's absolutely gorgeous here. Like, you know that we are in Amsterdam because there's a river right here and there's bikes everywhere else. And before we do this, I want to show you something, okay? This here, it's a wall.
Wow.
Okay, and if you look around here, like these absolutely gorgeous buildings, all of them, like many of them, I assume all of them are half a century, maybe a full century old. In construction, it's completely normal that we had absolutely no productivity increases compared to all the other industries. Farming used to be, I don't know, like 60, 80, 90% or something of the population worked in farming. I will throw the stats in afterwards. And nowadays it's like less than 10 because it's such a productivity improvement. But construction is different. Construction, we pretty much do the same way as we did like 100 years ago. Or people think of like prefabbed houses where you have everything in one big factory and then you just ship it out there, right? But that doesn't create these kind of gorgeous buildings. This doesn't create this kind of like quality you need, this bespoke, perfectly set up to the environment kind of quality. So how do you do this? And the answer here is like a company like Monumental. They're doing little robots that are producing these kind of houses brick to brick, the same way as a mason would. Europe is actually one of the leaders in using automation and robotics on construction sites. We are doing, like, we have more robots and constructions on construction sites than like the States or China. This is, like, oddly enough, one of the areas where we're a global leader, and Monumental wants to become the #1 company in that space, freaking worldwide. So let's go in there, let's meet Salar, let's meet the team, let's see what they do and have a good time. Hey, you're Salar?
Yes.
Hi, congrats, nice to meet
welcome.
you. Thank you for having me. You actually sold your last company to Palantir, right?
Yes, we started the company also actually out of Amsterdam, but we back then it was so hard to raise funding. That moved very quickly to Silicon Valley. And Sebastian, my co-founder, and I were both at Palantir for a couple of years.
What brought you back?
Quality of life for starting a family. And the other reason was that I actually thought that the Netherlands or Europe would be the best place to start a company like this one.
Yeah.
The US actually has like all these, well discussed advantages that everyone talks about all the time. We're in the construction business. There's actually no advantage of being into the US, right? Like, it's not a single market at all, right? Every state, every county, has different building codes. Union rules are different in every state, right?
Like similar problem of fragmentation as we have here.
So actually, like, the benefits of being in the US are quite limited, and I'd argue in different markets actually worse, right? Like, everyone knows and jokes that California is like the worst place to work, to build like actual housing, right? So like, this would have been like Silicon Valley would be probably the worst place to start this company.
Yeah. Especially in your space, Europe is surprisingly far ahead when it comes to automation on construction site. Mainly because of the intense labor shortage in that industry, right?
Yeah, and so I think that's the other one, right? Like, the need in Europe is right now is very severe, which makes just like the market demand is just like so obvious. I think we figured out a few things like as a company, but I also think just like the market is literally demanding this right now.
I think the most sci-fi imagination is people have like humanoids on a construction site, but like, why would I need a humanoid there? That makes no sense whatsoever. You know what I mean? So
I think the question I actually ask people is, if you think about a real construction site, do you imagine we're going to build humanoids and then we're going to put the humanoid in a forklift and have it drive a forklift? Or are we going to just like make autonomous like technology on the construction site?
What is this?
This is our 3D print farm. We do a lot of 3D printing here. It's just like speed of iteration, speed of learning. We bias our team to like, we ship hardware on a weekly basis. We have this 3D print farm. I'll show you the workshop. So we prototype really quickly, but then also for a lot of things, we actually continue to do like small series manufacturing in our office. We started approaching this from like a software perspective, and everyone likes to look at the walls, everyone likes to look at the robots, but everything behind it is like we've basically built like a full operating system that does everything from like running the robots, simulating them, doing 3D modeling of construction sites, right? Like we actually have to physically understand what they look like, what to build there.
What made you pick construction?
If you like old towns, right? Like I like, you know, we're in Amsterdam right now. I love Amsterdam. You walk around like the old part of the city. Everyone loves that part of the city. Everyone who can afford it wants to live there, but almost no one can afford it. There's almost no other industry where this is true, where if you have more money, you go to older buildings because you can afford it, right? Like that actually tells you something about like what is wrong. So that's the like kind of like almost, let's call it like aesthetic principled reason behind it. But the very practical reason, of course, is like I would argue that housing is probably our number 1 or number 2 political problem in almost every industrialized nation right now, right? Like in every European country, in most of the big metros in the US. But ultimately, if you can build more, there isn't enough labor to build more, right? So we're ultimately constrained by the labor to do it. And that, in my view, has only one solution, right? Like what worked for manufacturing, what worked for textiles, what worked for chemicals is more industrialization, right?
This is crazy if you think about it. Like
it's like so obvious in a way.
It
should be like close to existential. And then when you like zoom out even further, and then you realize construction's somewhere between like 10 and 15% of GDP in every country, right? Like everywhere in the world, that's how big it is, and how little like money flows into it from like VC money, startup money, like how much, how little innovation happens versus all these other industries. Like it is actually like shocking, right? Like it makes no sense because it's such a massive market. So you don't have to do like the dumb thing where it's like, oh, we're tackling like $1 trillion opportunity. Like that is where you're ultimately going to go. But even in the short term, you're already like tackling like multi-billion-dollar kind of like markets.
And if I understood it correctly, your business model is actually selling these.
Yes.
I have a construction site, and what you're doing is like you're selling this wall. Like you need this wall done. Here's a price for it done.
Yes. So one of the key insights we had is basically that what really works is being a subcontractor in this industry. Selling technology to construction is hard, but being a subcontractor is not hard. People love subcontractors. That's how the industry works. And the way subcontracting works in masonry or bricklaying is you get paid by the brick or the square meter. If we lay a lot of good bricks fast, we get paid fast for those bricks. If we don't get paid. But if we also do well and move faster, we're also going to become a more profitable.
Yes, and you just plug that directly into the business model that I know. Is this like an early prototype or like what is
this is our first prototype, kind of like reminding ourselves like how we started. So we started basically with this simple prototype, which is mostly proof of concept, but it built the first walls we've ever built, which are hidden there. We can actually remove this. This is the museum actually. This is like our mini museum of like fried PCBs, broken parts. Like who like,
it's too real.
It's too real, right? Like too many of them. And now I think like it's interesting to kind of like see where we've progressed. So maybe it's interesting to look at the robots first.
Yeah, please.
These just came back from a construction site like this morning. The way our technology works is we actually have built 3 main types of robots that work together. The main one that does the bricklaying is called Pisa. It's mostly an internal name, and
because it's a tower, or why?
It's a tower. It's leaning a bit. Like that's actually the joke. So you can see it has like cameras to localize it. It has cameras like on the AGV platforms. It has cameras on the end effectors, like over here. We built all our robots on the same platform, which I might actually be able to show you over there. So you can see like the AGVs as they come from the workshop in their pristine condition here. You can put different modules on them, right? So the design is completely modular. In here, they have compute, battery, and then we have like different, basically modules that go on top of it. So this one has 2 cranes that do, one does the pick and place of the bricks. So this is an end effector that grabs on a brick. And this one, you can see how dirty it is. This one extrudes mortar. This system could supply, you fill it up with mortar, and then it could supply that one autonomously with more mortar. And then we have another one parked over there that supplies the bricks.
What's the right line between efficiency of like reusing what the industry knows, like for example like these bricks, and like I don't know, coming up with everything custom?
I think that's a really, really important question, and we bias very strongly, oddly, to be very conservative here. So we basically use what the industry uses for a bunch of reasons. Imagine actually making the tiniest change. Let's say we change like the type of brick. We pick a custom brick. It actually suddenly means you have to change change the design of the building,
Yeah.
which means you have to actually like convince the architect.
Yeah.
You're introducing new building material, which now suddenly means that you have to like certify that building material in every country you're going to build or every jurisdiction that you want to build in, right? The GC, the general contractor, needs to be comfortable to build with it. The customer, the end customer, like the real estate developer, needs to be comfortable owning a house or a building that's built with a new material that might have never been used before. It literally changes the entire calculus. And then one person has to say no to your tiny change, like your new material, and then the whole project will fail. So you're never going to be able to like sell through basically and succeed.
Yeah.
And if you take that into account, you're actually going to become very conservative in those design choices. Like you want to keep the supply chain the same so that you can basically be plug and play as a subcontractor at any point in time. And our bet basically is that it makes some engineering harder, but it's totally worth it because engineering is actually easy for us. We're a hard tech company versus like solving all these complicated like salesy problems.
Shall we look at the site here? Because
Yeah,
this is like this is like looks too cool.
Yeah.
Yeah, I'm doing some R&D over here. I'm attaching a new camera to the end effector here. I think this can help us improve our accuracy. These stickers are fiducial markers. We use these markers to actually localize the robot. So the robot has some cameras over there. It looks at the world, and because we did a reconstruction, we know where the markers are, so we can know where the robot is, right?
We can maybe go into the workshop. I'll show you some more stuff as they're prepping this. I think like basically like we're at this stage now where we work with big stainless steel parts.
Yeah.
We've had like proper mechanical engineering going on here behind it. Like I think that's kind of like been the progression on the hardware side of the company where we started as software founders. We had a vision of what we wanted to build, and then we basically had to like build a team of people who actually told us how you actually build the stuff.
How many people are you? Like now 40 or something?
Yeah, 45 I think.
45?
46, yeah. You can actually see how everything gets assembled here, right? So I showed you like the platforms, right? Like the AGVs as they come. We have the arms. We build them as modules. Everything is modular in our system, right? They're assembled here. We have the towers. We have like an AGV that's still being built, right? You can actually see what it looks like from
so like
here.
that's before, that's
before,
after.
Yeah, kind of like stages. We build in batches. It's not like a factory line kind of setting. And we're still, every batch has like some iteration, some improvement compared to the one before.
Yeah.
Where we learn from construction sites. We're deploying everything, right? Because that's, again, unique. Like we're not talking about robotics as a like 5 to 10 year future vision. We are deploying everything. You can see how dirty they are.
That thing has been on a construction site in the last few days.
Yes,
100%.
right? Like you get so much like data points.
Yeah.
And then we iterate from it and like try to make a new batch within a month or two, right?
Yeah.
And that is like, I think the most important thing about our company, like the most unique thing maybe about how we
All about iteration of speed.
It's like stressful, painful, but I think the only way to actually build a company like this, there's no other way.
Forcing functions.
Yes.
When it comes to these kind of constructions, like in your ultimate vision, do you think that these robots will be able to also build in other seasons, like just make like, for example, like construction winter normal thing, or is it like down to the actual material that this is not an option?
Exactly, it's more about the material. So interestingly, actually building hardware that can withstand like bad weather is not hard, right?
Yeah.
Like, you know, cars can do it, tractors can do it. Like you can build like that. That's actually not like a hard problem to solve. The really hard part is, for example, like masonry, right? Like the bricklaying we do. The rules change when you're doing it under 5 degrees Celsius, for example. If you do it while it's raining, there's like real risk of staining. Like you get this kind of like white stain that you might have seen on some buildings. So it's more like material related than like robotics related.
Yeah.
So, but what I would say is like with robotics, one thing you can do is like speed up, both in absolute terms, but also just by deploying more robots at the same time.
Yeah.
Work in longer shifts, even 24/7 shifts. And so like, I'll give you one example. One of the crazy things about the Netherlands, but I think this is like Europe-wide to me, is there's like one big construction vacation in the summer, which makes sense, right? Like, I mean, people in construction deserve their vacation, so it's not like unreasonable.
It's in summer.
Right, but it's like a full month in August, basically.
No way.
Which is the best month to build, of course, right?
I didn't know
And
that.
then, of course, we go back to the season to build in September, October, November,
cold.
when it's like raining the whole day, basically, right? And like, so there's like all these kind of like, just like the way things are done in construction, whereas if you have like a robotic crew, of course, you're going to peak, in the good months, maybe run 20-hour shifts or something like that if you can. Build as much as you can, and then you're less prone to like bad weather when there's bad weather, right? So you can manage that in other ways.
Your vision is to have one construction overseer and like multiple robots on site?
Yes.
But more like that the person who's actually trained for masonry can focus on like monitoring the robots and the output.
Yeah, actually, that person doesn't even need to be trained for masonry. Like, the person we call a robot operator, like they don't need to be trained for it. Like, we train them in house, like specifically around things that we care about, like to understand the robotics and the end product. I think for our business case, it doesn't actually matter if we have 0 humans or 1 person overseeing like a huge fleet of robots, right? That's what matters. And so getting that leverage up, like going from like 1 operator per robot to 1 to 10, that's what matters a lot. And then bringing that person from 1 to 0 is actually like not that important to make this a big deal.
And just for my American viewers, this is a typical workshop in Europe. It's a cheap, normal building.
Yeah, this is of course like Lowe's.
I wouldn't even live here. It's horrible.
Like, yes.
So what's your origin stories? You sold to Palantir, and then you like explored this whole like where can you use AI? Then you found like construction. And what's the early days basically?
I did explore a few like other kind of like tangent concepts. So one of them was like autonomous infrastructure building, which I think is also a big problem. Like how you build like railroads.
Tunnels? Oh, railroads.
Yeah,
Okay.
railroads, but like anything, right? Like tunnels, but mostly railroads and roads, because those are also like insane kind of like we spend 100 million, I think, on a kilometer of road in Europe, for example, right? Like why is that?
Yeah.
But the thing that struck me is housing is just like a very, very kind of like real motivating problem to work on, right? Like I think it just affects everyone.
Real, it's very tangible, right?
It's very tangible,
you
right?
Can explain to your grandmother.
Yeah. With brick walls, I think what I love about them is you could literally start with the tiny walls I showed you.
Yeah.
We built like a wall for a shed for a contractor as a first pilot. We did a wall for an industrial building. Now we're now doing like housing developers. We're doing like dozens of buildings at the same time. So you're scaling up, right? And we're going to do hundreds of buildings at the same time. I think that's what's really cool.
So you're actually already doing like the full building? Is it like
all the masonry for the building? Yes. But
really? Wow.
Yes.
Okay.
Well, we took it
put
on.
this into context, for example, like if you would build some house like this, the whole outside, the whole inside.
Yes, all the brickwork we could
And you
do.
started how many years ago?
3 years ago.
This is insane.
Yeah. Right.
Okay.
So like
and the normal thing you hear in robotics is like 5 years out to the first customer kind of situation.
Yeah, and that's actually one of the things. Like we actually went on our first pilot, which was not a huge success in terms of like within a year. Like we founded the company, and then a year later we had a robot that was building a wall for a customer. I actually used Boston Dynamics specifically as our counterexample. Like it's a very cool company. They build cool technology.
And they have cool videos.
And they've been stuck in like this 30-year-long like R&D mode. And I think that's exactly what we didn't want to be. We wanted to actually like fix a problem in the market with a high sense of urgency. We self-funded for like a year to answer your question. Like I think it was mostly Sebastian and me. We started hiring a couple people to help us as contractors, and then we raised a 3 million seed round.
What was your motivation of raising a seed round if you already have like an exit and everything?
I think at some point it's also just like it feels like you make it real. I think it's also like signaling to people that you hire that external. I think like the validation of
it's not some crazy person's pet project.
It's like otherwise it's literally like you're a crazy person with some money that is just trying to do this thing. Especially if it's I think such an outrageous thing. I think getting some kind of like stamp of approval is helpful. You want to go into
your office doesn't stop, does it?
But we can also just pretend this is like the way all real estate looks.
No, this is like honestly, this is like a baseline office, I would say.
This is like a big European city, right?
Like I think Americans have no idea what we mean with quality of life.
Yes.
Like that's the baseline.
Yes.
What was your experience like when going fundraising? Like you obviously had like a different background than most first-time founders in Europe. You had like the network of success. You already had like early prototypes through self-funding. But like, what was your experience with coming like of basically such an outrageously ambitious project to investors in Europe?
I think honestly, like especially with seed, it was very helpful to be a second-time founder. Like you do get like a huge benefit of the doubt. I believe the VCs that backed us, Hummingbird especially, they basically literally told me, this is crazy. It kind of makes sense, but who knows? But we are comfortable making a bet on you. I still think like first-time founders can still pull it off, by the way. I don't think it's and I also think the market to do like a hard tech thing like this already in 2025 is much easier than 2021, right? Like 2021. What I would actually encourage like other people is like if you are doing something real, there aren't a lot of like high quality startups doing hard tech, right? Like the market is not saturated with them. And so if you basically like define a vision and make it real that you can actually make this real, whatever it is, whether it's nuclear fusion, whether it's like autonomous construction, I actually think it is possible and maybe easier to fundraise for that, right?
Yep,
like the harder the problem, and again, also like with getting talent, it's easier to hire amazing talent when you're doing something so ambitious, right? Like ambitious, talented people want to work on these problems, right? They don't want to do another optimization, right? Like so you actually like self-select the right people, and I actually think it like makes it easier to solve these problems.
Shall we check it out?
Let's see what's happening.
Hi, I'm Tobias, and normally I'm actually a software engineer. I work on mostly like the front end of our application, but every once in a while when the sun is out, I'm also here ready to build a wall. And so what you can see here is basically our system doing its thing. We have Petra, our brick supply robot, and that one keeps me from basically having to feed the brick to the gripper every time.
Petra because of the stone? Like
Yeah, exactly. The previous version was called Stonehenge, so that's the naming scheme. Then we have Pisa, because it's like a leaning tower, you see. And that one has two arms, one to lay down the mortar bed, and then the other to actually put the brick.
It's putting the mortar, and now it's putting the...
Yeah, exactly. And in the meantime, that one goes to refill. That's our third robot. It's called Panama. Its goal is basically to refill the little mortar hopper here. Basically here in our application, it's a bit dark now, but we can basically see a live view of how the robots are moving and if everything's working fine. We make a wall design based on basically what the architects want, and then we just need to enter it into our software, and then we're good to go basically.
This is crazy. This is like all of the individual robots. This is the actual wall that we see here.
You could probably, you
This
can
is
just like, this
crazy.
is an actual like 3D model, right? Like it's a rich 3D model. You can like move around, like of the building you're just standing in front of, right?
This is awesome. And if you would move the robot, it would automatically update itself because it all has all the
Yes,
visions.
yes.
Okay, like
So if
okay,
he-
move the arm up.
He moves it up.
Oh, that's funny. Okay, yeah,
I'm just like physically doing it right now.
yeah,
right?
yeah.
It's like a full digital twin.
Yeah.
That's so cool. Okay, now we're back. This is actually gorgeous. Let's be here.
This is where we calibrate our robots. You asked me why is the robot called Pisa? It's because it's leaning. Why is it leaning? It's actually because we try to manufacture them as cheap as possible. So we're trying to keep the bill of material as low as possible, which is like an actual business goal, right? Like if you make a €100,000 machine or €200,000 machine, it will make your business case look worse.
Yeah.
How do you make like a leaning robot and still that builds good walls? You calibrate it.
Okay.
So we put it here, and we have this whole camera set up. You can actually see it around us.
Yeah.
And we actually have like all kinds of markers, and like you see all these kind of like physical like objects it can grab on. Like it's too complicated to explain. And then the robot will basically do its dance. And as it's doing that, we're looking at every like end effector, everything in like sub-millimeter position space. And we characterize that robot, like whatever, like, you know, maybe the arm is like a millimeter long, or maybe it's leaning a bit
Interesting.
more.
So you have like a digital dummy per individual unit?
Yes, so a robot comes out of the workshop, we bring it here, we calibrate it, and then they behave the same. And it actually makes manufacturing easier and cheaper.
If you do like this kind of project, like if like hard tech, ambitious startups, doesn't even need to be hard, but like in general, like this kind of like, hey, we want to be the #1 company in that space worldwide. Like, what's your job as a CEO?
I think ultimately the CEO's job is probably like three things, right? So one is set the vision, right? Like say what we're going to do, tell that to everyone, repeat. You just said this to me, right? Like you just repeat the same thing over and over again. You think you've said it, say it again. I think there's like the long-term vision. There's like the kind of what are we going to achieve next year? What are we going to achieve in 3 years, right? Like that's kind of like the main job. And then use that vision to get the capital and build a team, right? I think those are like the things you can't really outsource, right? So then you have to build a team, you have to get capital to the team, use the vision to like sell it to VCs or whoever like supplies you with capital, you hire your first people, and then you start executing towards that vision, right? Then you have to show that you can do it.
What's the fine line between long-term vision and short-term execution clarity?
I talk about like autonomous construction in general, right? Like autonomously building houses, but we've been very clear, right? Like you can't just do that from day one. So you start with a single product line, bricklaying. You start by building this platform. You start by focusing on a single market segment, right? Like single family homes. We're not doing like skyscrapers today, right? So it shows that you're thinking about segmenting product, but also that when, you know, if you ask me, I can tell you what is the next product going to be? Probably like limestone blocks, concrete masonry units, right? Like adjacent blocks. We're not suddenly going to do something completely unrelated. So you start thinking, or like, oh, there's an actual like real product roadmap.
How do you prioritize? So for example, like you could scale geographically.
Yes.
You could scale by use case, as you just mentioned, like different blocks. Like how do you decide for yourself, like what's the best to focus on early on?
I think the most interesting thing to me is I think them building an organization that can scale on more than one axis. I do think that is actually like an important trick to figure out so that you can do two things in parallel. I think that amazing example was of Revolut, right? Where they went both for geographic expansion, but also figured out how to like launch new products all the time and like how to like navigate those two axes. I think that is like building the organizational structure that can support this is probably the most important thing you can do next, like in the next phase as a company, like towards like Series B. We are thinking about how to do this basically, but we basically want to do both, right? We want to expand in new markets, also because there's like a ton of market demand. We literally have subcontractors, general contracts from other countries flying into our office to get demos and ask us like, when can you start deploying this in our country, the UK and Germany? And so we definitely want to serve that demand. But we also like want to start showing that our technology is so easily, applicable to bigger blocks, right? Which is actually like another like multi-billion-dollar market on its own. What I don't know is construction is so big. Well, does our technology enable us to do foundations easier? I don't think so, not today. Or will it allow us to do like finishing, like whatever, like installing a kitchen? No, right? Like it's so I do still think like. There's a big segment where you're going to have a winner-takes-all dynamic where I would argue that we're already like on the way of being that player. We don't have that many competitors that are trying to do the same thing. But they're still against a multi-trillion-dollar industry. And so there's so many segments you can like carve out, whether it's like infrastructure, finishing of housing, like whatever, where it is possible that we'll see a couple other players also emerge.
The other interesting aspect here is because you own the AI models, you own the robots, you bring the robots to the site yourself. You have this full loop, not only like of human learning, but also like of machine learning. The company who has the most customers with the most robots out there will also have the biggest amount of useful data and therefore has like a runaway advantage, right?
Yeah, that's completely true. This is actually something where even the biggest players, like I think if you have Google with their whatever, like DeepMind, they don't have that data. And actually getting access to construction sites is not that trivial to actually set up that pipeline.
This is like one of the most interesting aspects right now about hard tech. To some extent, this is way more defendable than Meta doing yet another LLM or DeepSeek or whatever, right? I mean, so you have like, this is like a completely different play. And to my point of view, this is almost like where a lot of AI will move towards. Because you cannot compete with Google or Meta on budget, or like on scraping the internet because it's anyway done, So you need to find areas where Google can't go and just buy all of that data if you want to go in there.
Yes,
so,
100%. And back also to the human and the machine vision loop. So I think if you'd ask me, what are the challenges we see today, right? We deploy the robots and then there's a challenge. I think what fascinates me about is that a very big part of the problems we're encountering today are the kind of things where no one at the moment where we have the problem knows what the answer is. No one in our team, but actually even the people on the construction side need to think about like, how would we solve this problem? And it's not online. You can't search for Google. So it's very tacit construction knowledge. And then like a foreman who's senior, he will just tell you like, this is the way we've always done it. It's actually like tacit knowledge that is not encoded anywhere else. So meaning also that no AI model will access it, right? Unless they will start interviewing like whatever, like elderly craftsmen. All these questions are not easy to answer. They're not in books. They're not textbook problems, right? And so they only work when you're like deploying in the real world and like have that like full feedback.
As real as it gets. Cool, awesome. So like that being said, I think the next thing we should do is like actually visit one of those construction sites.
Yes.
Which we do tomorrow in the morning.
Yes.
And which will be basically only one quick cut now. Okay, so we are now at the one of the construction sites of Monumental. We're going to meet Frances. She's going to show us around a bit. And I have to wear a funny hat because that's apparently something you have to do here for liability reasons. And so let's watch some robots do work. Hey, you're Frances?
Yes, I am.
Hi, nice to meet you.
Yeah, so we're building this whole building. There's like 8 houses and the brickwork goes up to around 3 meters. And then these guys are doing the stickering. So this is like the first part of our process where we put all the markers and then take lots of photos and build a reconstruction so that we have a model in our software of the whole thing.
And the way I understood it, it doesn't matter too much where the sticker is as long as it stays at the same place.
Exactly, yeah. Which is tricky in the wind. A few of them have flown off already. But yeah, so here you can see some of the stuff that we've done. We've only been here for like a couple of days, so making fairly good progress. But it's always a bit slow at the start because it takes us a while to set everything up.
So how quickly can this wall be built? Or like how long does it take?
So this one I think was started yesterday. So we're building up to 3 meters tall.
Okay.
And I think we've got like 4 weeks to do it or something like
Okay.
that. Yeah, so the building itself is actually quite fast. It's more so like moving all the robots around, like setting up the platforms, the logistics stuff, and then aligning our walls to the real world.
So from your point of view, is this still like an, let's say, you know, like pilot project style, or is this like already full production, or like, how do you think like what's the scaling version of this? Will this be like even more robots, or will they be just like very much faster, or like how do you think about this?
Yeah, I think we're trying to get less human involvement, obviously. So like at the minute you kind of need one person per robot set. But we're working on more automation so that you can kind of have one person for like maybe 2 sets and then building that up.
Yeah.
And then, yeah, obviously making the robots build faster as well is the next step.
So the idea, So basically the idea is to make them faster and more reliable so that you don't need to babysit them.
Yeah, exactly. Yeah, that's the goal. And then we can start running them, you know, at all hours of the day, which obviously a person can't do. Like they can't be working through the night, and also, you know, on the weekend, stuff like that.
What is typically the kind of feedback you get from other construction workers or like from other masons? Like,
yeah, it kind of varies. Some of them are like very impressed. They think it's really cool. Others are, you know, more like just like to heckle us and tell us how slow we are. But yeah, we take that as like them, as praise really. Like if they're a little bit threatened by it, I don't know. But yeah, generally the vibe's pretty good.
did they not learn not to bully the robots?
I know, yeah, so rude. No, generally everyone's pretty friendly and like, yeah, everyone just thinks it's very exciting and cool to see, so it's nice.
What's roughly the cost structure compared to like normal masonry or like normal constructions like this?
So we get paid exactly the same as a mason.
Yeah.
So the business model is basically we get paid per brick or per 1,000 bricks laid. That price is the same as that a mason would get. So for the general contractor, the cost structure is actually exactly the same and what they're used to. I'm head of business development.
And this is business development?
Yes.
This is fucking cool. Like work in a fintech company, sit in a suit all day, have like sales calls all day, or like do this, like seriously?
Yeah, no, so business, like construction is like not your normal industry in terms of sales, right?
Yeah.
It's not a lot of cold calling, like emailing, stuff like that. Like we need to, because we're not selling our robots, we're not selling a service, we're selling an outcome, right? We're selling walls, like build walls.
Yeah.
So making sure that we deliver on our promise and deliver a good product, selling walls, is a big part of the sales cycle that we have here at Monumental.
Cool. Cool, thank you so much. And this is why Monumental is one of Europe's most ambitious startups. Thank you for having me.
Thanks.
Let's get out of here, it's freaking cold.
Yeah, it is cold.
Bye-bye.